class number 18. In this class, we will use the same topology to discuss how we can control the routes which are received from the neighbors, and also how we can control the routes advertised to the neighbors. So in the previous topology, we know that we have configured the BGP on all the routers to advertise routes from PC1 to PC2 networks, from R1 to other routers. Same thing from R5, advertising PC3 and PC4 networks to all other routers in the topology. So let's verify how the routes are advertised from R1. So on R1, I issued a command show IP BGP neighbor, and the neighbor IP here I am giving R2, and I am asking what are the routes I am advertising. So ideally we should expect to see, based on the configuration, we should advertise 1 and 2 networks. We can see them, but also you can see 3 and 4. So R1 learned about these routes from the R4 145, and it is advertising these routes as well to R2. So we didn't give any network command, anything, but so as these routes are learned by the BGP process, it is also start advertising them to its other neighbors. So R1 received these routes from R4 and it is advertising it to R2. Okay. So let's see on the R2 what happens. So on the R2, I'm issuing command show IP BGP neighbor, and neighbor here is R1. And what are the routes you are receiving from the R1? So it is receiving 3 and 4, but if you see, they are not the active routes. They are valid but not active routes. So I'm next checking what are, from the R2 standpoint, what are the routes you are learning from R3. It is also learning about the 3 and 4 from this direction. So now R2 is receiving about these networks from R1 and R3. So as this is less number of ASAPs, it is installing this route. But what we want to avoid this in this topology is, we don't want R1 to advertise these 3 and 4 networks, because 3 and 4 are basically connected to R5, and we only want R5 to advertise these routes. We don't want R1 to advertise these routes. Okay. So we don't want to advertise these routes to the peers. So let's see how we can achieve that. So in order to control what are the routes you are advertised, or what are the routes you want to receive from a neighbor, you can use a feature called route map. So route map will have two functions. So route map will be actioned against the matching prefixes, means matching networks, and also it can set some BGP path attributes. We are not discussing anything about the set feature now. We are only discussing the match condition. So let's see the configuration part. So in the previous configuration, we didn't have any route maps, but now we want to apply the route map here. So the first step is applying the route map to the neighbor, so that we can control what are the routes we can receive or advertise. So in this case, this is the R2. So I'm trying to apply a route map. The name of the route map is, I'm just some descriptive name. RM stands for route map, and this is the route map of R1, and the direction is out, advertised routes. Okay, so this is just the name, and it is applied in the out direction, means for advertised routes. Okay, basically what happens when you issue this command is, whenever BGP is trying to send advertised routes to its neighbor, this neighbor, it will look in this route map and will act accordingly. So let's see what is the route map configuration. So route map configuration is, you go into configuration mode and you type route map, and then you will give a name. So I'm just giving some descriptive name, and then you can have permit or deny statements. So if you do permit, means you want to advertise this route. If you give deny, you don't want to process that route or advertise that route. And there is some sequence number. So you can have multiple statements. Roadmap is like a list. You can have list like 1, 2, 3, 4, 5, 6, 7. So you can have multiple lines in the same roadmap so that you can do different actions. So in this case, I just have only one entry, which is 10. Okay. So what is the content of roadmap? It is trying to match. It want to permit the routes which are matching IP address defined in this prefix list. So prefix list is nothing but a list of networks. Okay. So I'm giving the some descriptive name PL prefix list of R1 in the out direction advertiser networks. So let's see the configuration of prefix list. IP prefix list and the name. Then we can give all the networks. So the 1, 2, permit, and these networks. So don't confuse with the permit in the prefix list and in the route map. In the route map, the permit stating that you want to process or advertise that route or not. If you give permit, it will advertise. If you give deny, it won't advertise. And it will work against whatever the match condition you have, right? So to avoid confusion, what you can do is, if you have permit in the prefix list, means check for these entries simply. Okay, if you have, for suppose, sequence 3 deny something 14.14 something, it basically it is not in this list. Okay, if you have deny means it's not in this list. So it might be confusing for you now, but we will use this deny statements in advanced configuration when we have multiple route map statements. For now, if you see deny in the prefix list, means basically the entry is not there. Okay. So now you apply this. First, you, in order to apply the route map into the neighbor, first you need to create the route map. In order to create the route map, you need to already have some prefix list configured. So in order to create any route map, first you need to create the prefix list. First step is prefix list. Then you create the route map, and here you will attach the prefix list. Then you will take this route map and will attach it to the neighbor. Okay. So when you want to verify the configuration, you will do in the reverse, because first you need to check what route map is applied to the neighbor. Then you should check what is the route map, and then check what is the prefix list. But when you are configuring, first you need to create the prefix list, then route map, then you attach it to the neighbor. Okay, so once we applied this, we can see now R1 is advertising R2 only 1 and 2 networks. So we don't see 3 and 4 here. Same happens here as well. But you might have a question. With this prefix list, we are only telling to permit, means whatever the routes in this prefix list, advertise them. So we are advertising 1 and 2, but we are not telling not to advertise 3 and 4, right? So we didn't add any deny statements for not to advertise 3 and 4 networks, because there will be implicit deny when you create a route map. Let's see. So we can see that why we are not advertising 3 and 4 without the deny statement in the next slide. For now, to verify the configuration, so R1 has route maps. First check the route map bindings. So peering to R2 and R4, there is a route map called RM R1 out, RM R1 out. It is applied in the out direction, means advertised routes. If you want to apply any route map to control the routes receiving from the peer, you will change this direction into in, and also you configure the route map accordingly. So then we see what is the route map content. In the route map content, it is stating that it has one prefix list matching. In the prefix list, you have these 2 networks, but we don't see why 3 and 4 are not being advertised, right? Let's look at the implicit. So whenever you configure a route map, this router will always have a default route map. So the default route map content is deny everything So it will have a match statement called all. So and then the action is deny. So whenever you configure the route map, you need to write all your statements based on the requirement, and in the end system will add implicit. So it will deny, it will take actions whatever you configured, and if nothing is matching these statements, then it will be processed by the implicit deny. So in this case we are telling in this route map permit 10 and matching the prefix list of this. So for the 1 and 2 routes this rule will be activated, and as we are permitting this will be advertised to the peers. But for the 3 and 4 it will not match this, and there is implicit deny. So that's why 3 and 4 networks are matching the implicit deny route map, so that they are not being advertised. Okay. So let's see when we have multiple statements how it will work. So in this case we have the same route map, but we have 3 statements in the route map. So one is permitting, permit, and the next one is deny, and the next one is again permit. And if any of the route does not matching any of these, it will be processed by the implicit deny, which will not advertise the route for any network which is not listed here. So for each route map you can have two things. So first thing is where do you want, which routes you want to advertise or match. Okay, so you can use prefix list, access list. There are number of features you can match against. Also you can set certain BGP path attributes that we will discuss in the next class, but for now you can also change some routing information as well. Okay, for suppose you can add some AS path, or you can add some metrics or anything. Okay, then if you have deny statements, means you don't want to advertise or process these routes. In this case having set has no use, because you are not doing anything with these routes. So that's why I striked out this out. And then you have some other permit statement, and you want to match against some prefix list, and you want to set some actions. So each route learned through the BGP process, when it wants to send to the peer or neighbor, if you have route maps configured, it will go and check one by one. So once it matches one entry, it won't check the next one. For suppose in previous case the first entry is matched for 1 and 2 networks, so that's why it didn't check, go to the implicit policy. Okay, so now I have created another route map. Instead of denying 3 and 4 networks using the implicit deny, I just want to configure a deny route map as well. So let's see. So let's verify the route map for R2. It has the same route map in the out direction, means advertising routes to the peers, to this peer. So let's verify the contents of this particular route map. So it has two statements. One is deny 5 and the next one is permit 10. Okay, so let's see what we have in the deny 5. So for 111 network, let's see what happens. So let's see if this matches this rule or not. So R1 out, it has prefix list deny. So let's go and check. This is the prefix list. So basically in the prefix list, as I mentioned before, if you see deny statements, means these are not existed. Basically they are not there. Okay, that's how you can remember easily, instead of confusing with the route map permit statement. If you see deny in the prefix list, just ignore those things, assume like that they are not there. Okay, so 1 is matching, no, there are only 3 and 4, so it will not match this route map. Okay, then it will go and check the next one. The next statement is matching prefix list R1 just out, so it will go here. So here it is matching, and what is the action we have here? Permit, so that it will advertise that route. Same thing happens for the 2. Okay, let's see what happens for the 3 network. So first route map statement is deny 5, and it is has a prefix list match. So this is the prefix list. So if you see, deny means these are actually not there in the prefix list. So you have 3 here. Okay, it is matching this prefix list, and this prefix list is matching against the first route map. So we will deny these routes being advertised. So same thing happens for the 4 network as well. So we hit this route map for the 3 and 4. For the 1 and 2 we are hitting this. Okay, so we are not hitting the implicit deny now. Okay, so to have better control what are the routes you are receiving or you are advertising, you can control them using the route map. Okay, it's always a better practice to not to use the implicit one. Okay, so lab for this class is apply the same route map, the one I discussed on the R1, and verify you are only advertising the routes 1 and 2 and you are not advertising 3 and 4. So apply the same route map on R5 side. So I didn't give the configuration, so but you should create a prefix list, then a route map, and attach it to the neighbor similar way, but the networks could be different in this direction, because from R5 you only want to advertise 3 and 4 but not 1 and 2, because R5 will learn 1 and 2 this way. Okay, so you can remove them. Then you can play with the permit and deny statements with the route map and prefix list, so that you will have a better understanding. So just to avoid confusion and have to give more clarity, when you see deny statement in the prefix list, just ignore that configuration. Okay, so that's all for this class. In the next class we will discuss about different BGP path attributes and path selection process. Thank you.